So, Sharath and Barney both, I've heard, most of the people, we have heard about only two. All right, supervised and unsupervised. But we hear that there are other things as well. All right. So, could you just tell me what they are? Sharath, you could probably start. Tell me what they are, and probably just give some definition about what is that.
Um, Thank you, Nitin. Yes, I would love to answer that question. But before I jump into your question, I just wanted to add some more points, or at least a couple of points from where you have left explaining about the clusters to our audience. Um, the important point, yes, rightly said by Mr. Nitin, that when you do not have large data sets, you probably would have not experimented by doing the clustering. A lot of people, they just keep it aside because ultimately when you do the clusters, your data set comes down to a small number. And on top of that small number of samples, you would definitely not really enjoy working on because your models will not understand the patterns. But saying that, as part of your descriptive analytics or multivariate analysis, I would personally recommend you all that irrespective of the size of your data set, to understand the information that your data has, you always try and do this clustering as a random practice, just as part of your EDA, how you do univariate analysis. Just ensure that you do clustering. It hardly takes time, right? If you are familiar with the code and the logic, it hardly takes time to just do that clustering and try and understand what each group has to say. Of course, when you're trying to build your prediction models, proceed with the entire data set as a single data set if you have limited quality or limited quantity of the data. But as I said, try and do clustering or any unsupervised learning technique, because ultimately it describes the data better. This is one point that I wanted to add on top what Nitin has mentioned. Coming to the question on what are the different types of the learnings, right? The machine learning algorithms are categorized into. I'm pretty sure majority of you people have stuck with unsupervised learning and supervised learning. This is because you have only studied these things, right? Probably in books, or probably the trainings that you had, or probably the learning curve that you had limited access to the content, or you're just starting. So you probably will try and stick to supervised and unsupervised. But there are other techniques like semi-supervised, which is predominantly applied subconsciously, even without your knowing that you're applying semi-supervised, you sometimes apply that. We have reinforcement learning, we have self-supervised learning, we have transfer learning, right? So there are different types of learning algorithms out there. Now, I would definitely like to add the definition of semi-supervised in a way that you can easily understand. So let us assume that there is a data set where you don't have the variable of interest. We call it as labeled data, right? So when you don't have a labeled data or variable of interest, there's no way you can actually build a supervised model, that is prediction models, because you need a historical data to develop a kind of a mathematical equation which can explain the relation between your input variables and the output from the historical data. But here in this case, the example that I'm taking, you don't have a label. Now, in such case, again, we go back to unsupervised learning techniques, for example, clustering. This cluster exercise can give you the cluster ID, and that cluster ID can become your label. Once you identify this label, right, you can try and proceed using supervised learning techniques by considering the cluster ID as your output variable. So this is basically allows you to also come up with your prediction models on a data set where you don't have a labeled data. This is semi-supervised learning techniques. Of course, unsupervised is predominantly used for descriptive analytics where you don't have a labeled data. Supervised learning techniques are basically used for doing prediction models where you have labeled data. Reinforcement learning is another technique that basically is used for, you say, reward-based learning, or you can also call it as penalization-based learning. If the agent does the right thing, then the model gets points. You can say it's like a video game where the agent hits the right point, then it gets good points. If it is not doing the right thing, then the player dies in a video game, right? So it's kind of reinforcement learning. By doing multiple times, the algorithm will learn. And we do have other techniques as well. I just don't want to capture the entire time here. So
yeah. It definitely gets a little, we get a little animated when we are in our favorite zone and in our comfort zone. We want to tell more about it, especially from our experience. So I could make that out. So, but we'll try to, get back to the focus with reference to the types. Predominantly, what we are going to discuss is the types and how it works. We'll be sticking to that. And then if time permits, we'll move into some more depths of it. So yeah, Bharani, the baton is passed to you. So apart from the usual supervised, unsupervised, what insights can you give with the remaining types of learnings with your experience?
Sure, absolutely. So before that, I want to first quickly give one-liners for supervised, semi-supervised, etc., so that when I talk about self-supervised learning and probably reinforcement learning, people will understand better. In supervised learning, within the historical data, you will have the output variable and input variables. You will have the target or label and the features. In my project, we wanted to predict whether a person will default on the loan or not. That was the output variable, target or label, different names for that. And we had a bunch of inputs such as age, gender, income, so on and so forth. Features. In unsupervised learning, wherein we applied clustering, in that we started treating this output variable as another feature. And then we built clustering algorithm on top of that. Because for unsupervised learning, the output variable is unknown. Even if you have the output variable in your data set, you mimic as if that's one of your features, inputs. Then we have semi-supervised learning, wherein within the entire data set, for example, if you take image-related business problem, one of the cancer prediction models that we have built, in that we had close to 6,000 images. Out of that, for 3,000 images, we had a label, whether that particular image was malignant or benign, whether there was calcification, right? So on and so forth, whether it was fatty benign, fatty malignant, and a bunch of other classes were there. For 3,000 images, we had the labels. For another 3,000 images, we did not have the label. We had to either hire a radiologist who would probably charge, I would say $100 per hour. And just imagine in 100 hours, probably that radiologist would be able to label 5 to 6 images. Given that we had 3,000 images, it would have been a huge investment for us just to give labels to the images. Hence, what we have done is, using the 3,000 images which we had, for which we had labels, we built a prediction model on that. And once we built the prediction model, we applied that onto the remaining 3,000 images. And we had the predictions of all the 3,000 images on whether the image was malignant or benign, etc. And then we combined all of these 6,000 images to build one comprehensive model. So the usage of semi-supervised learning here is to just get the labels for the data where we did not have the label. This is semi-supervised. Then we have self-supervised learning. Self-supervised learning means from your inputs, you try to learn your inputs. Okay, what do you mean by that? If you take an example of NLP, natural language processing, given the text, given the words, some words might be missing for whatever reason. Maybe when you scan the document, it didn't figure out that particular word properly. Maybe there was a blank space or whatever might be the reason. So your NLP would learn those words, which are your inputs, and it will predict the missing words. So inputs are taken to find out the inputs. That's self-supervised learning. And then you have reinforcement learning. Within reinforcement learning, if you have huge number of rules, for example, I'm sure a lot of people invest in stock market. Should I invest in Google or should I invest in Microsoft or should I invest in Facebook? How many units of stock do I purchase on Facebook? How many do I sell pertaining to Google? How many do I need to retain pertaining to Microsoft? In that way, you have thousands of companies which are being traded on stock market. Where would you invest? At what time would you sell? How much quantity would you sell? How much quantity would you retain? Oh my God, it would be a Herculean task. In these kind of scenarios, you resort to reinforcement learning, where you just define an objective function. What is your objective when you invest on stock market? Obviously, you want to become Warren Buffett, right? Or Rakesh Jhunjhunwala. And obviously, your objective would be to maximize your profits. So you just tell to your reinforcement learning that I want to maximize the return on investment. For the money that I'm investing in stocks, I want to increase the return on investment. That's it. And reinforcement learning would learn all the patterns. Okay, at this time period, you sell these many stocks. At this time period, you purchase these many stocks. At this time period, retain. Don't do any trading. So all these rules, which otherwise are very daunting, would be learned by a reinforcement learning. So that's how it's going to work.
Thank you, Bharani.